Hello, and welcome to The Agent is In. This is episode 61, and today we're going to talk a little bit about one of our libraries, Libntech. Craig, you want to tell us a little bit about Libntech or the history, where it came from?
Yeah, so it's a Northern Tech library of utilities and functions and such. That's where the name comes from, Lib and Tech. And it comes from CFEngine core, which is a open source public repo. And so over the 30 plus years that core has been around, many things have been developed as helpers for various parts of the system. And we, some years ago, about 7 years ago, I think it was 2019, we took some of those out of core and made it its own repository and linked it into core as a submodule, a Git submodule. So that's what Libntech is. And let's see if I can share my screen. I think I can.
And then today you're going to show us like how to use that library to make something completely different.
Correct. Right. So here's Libntech. It's a repository in the Northern Tech HQ organization. We'll have show notes up that'll have all the links. Here's the show notes. That'll be up on our blog. So yeah, this is Libntech, and if we look here, we can see there's some instructions and like the license, and so the main thing that Libntech provides is a whole bunch of utilities. So data structures, arrays, maps, sequences, buffers, parsing and writing like CSV, JSON, XML, dealing with files, dealing with strings. There's a logging utility in there, regexes, so dealing with parsing and grabbing things and capturing parts of regex. Yeah, so just a whole bunch of stuff in here that we've assembled over the years. And there is an example project, a repository, which is a special kind of thing in GitHub called a public template. And so core uses Libntech as a submodule, and this project here, which you can use as a template, also does. And it includes the auto tools business that you need to kind of get things to go, as well as a little sample program called argv printer, which kind of shows off the size of the library and whatnot. Okay, so
how big is the library?
How big is the library? Big. Good question. How big is it? We could look at the stats from GitHub. Let's take a look. It's over here somewhere, isn't it? Down here somewhere. Here we go. Oh, I guess that's just percentages. But yeah, not really sure like the LOC as they say, the lines of code, but it's medium size, I think. Not terribly huge, but big enough with lots of features. So in order to start using Libntech, one of the easiest ways is to just use this template, create a new repository, and then you get some, get to choose the name, et cetera, et cetera. I've done this with this JSON command repository that I have here. And
what's special about when you create from template, your commit history?
Yeah, so the cool thing about that is that you get kind of instead of cloning the example, you get like a fresh no commit history repository. So my JSON command repository has 15 commits, the initial of which is, I don't even know what the initial says, initial commit, and that's literally something I did. So I don't even know if that's generated by GitHub or not. Let's take a look. Yeah, I'm not sure.
That looks like that's probably the copy.
Yeah, I think it's the copy. Yeah. Okay, so that's the initial commit. All right. Yeah, so what I wanted to do, we've got a task that we're working on where we need to parse some JSON content and then manipulate it in some ways and then kind of send it along. So I thought, using Libntech obviously makes a lot of sense because we're going to put this code in the CFEngine, and Libntech is available to our C code bases in CFEngine. So with the example template, I created that, and I made a new command. So I took the kind of example of that argv printer command in this auto makefile.am, and added a JSON command. So here's the bits and pieces. I'm just going to add a json.c. And for starters, I just made a real simple one just to make sure that the auto tool stuff worked, and indeed it works. So that's nice. A lot of times auto tools can really give you some trouble when you first start a project. So then the next step would be to use some of the libraries in Libntech to do some stuff. So first task is just to, let's read a file in that's JSON or from standard input and parse it, just make sure it parses it all. So I used a couple of things from the file library in Libntech. Safe open, which handles a few odd cases so you don't have to. Path exists, which just checks to see if a file exists, which you can do a stat, but this is just path exists, and then you give it a string parameter for the function, and it just returns a Boolean. So it's super easy and reads better in your code, I suppose, if you're kind of not initiated to all the details of Unix system calls. And then file read from file descriptor, I use that so that I could either read from file descriptor 1, standard in, or whatever file descriptor I get from the open file. And that turns out was pretty easy, and it all works out, as you can see here. Okay, so then the next step was subcommands. So a lot of times, you might have flags or arguments. I didn't really want to deal with that, so I chose to just use subcommands. And so I used this string starts with function from the string lib. That's pretty nice. So I thought it might be nice to have shorthands for the commands. So I was going to do check, print, and query is eventually the eventual goal of like digging into the JSON. So I can just replace that with C, P, and Q for query. So yeah, so here I'm showing I've got JSON P, which is the first subcommand, print, and then just the name of the file or from standard in. And yeah, it works. It pretty prints it out. Great. Then what I really want to get at is looking at some output, coincidentally, of in a container engine. What instances are running, what are the details of those. And so I needed to get out like the ID, for example. So I wrote a kind of a simple path expression query engine here. So obviously there's JQ, which has a whole complicated query language, which is very expressive and can do all kinds of things, but we really don't need that here. And I'm not interested in shelling out to JQ or using it as a library or anything like that, especially when the use case we have here is fairly simple. We just have to find a few needles in the haystack, nothing too complicated. So I was able to use the regex library that we have in our, or actually not quite that step just yet. Yeah, so I was able to do that work without too much more trouble. One of the things that I learned a lot here is kind of the power of the JSON parsing code. So I'll show you that a little bit. So I wrote a query function, which there's a whole API here of getting the element type of an element. Is it a container, aka a array or an object? And then once you know what kind that is, you might need to iterate over the object, pulling out the keys and the values, or the array, just going through the iteration of the elements. And if it's not one of those, then it's actual value, and then you maybe just want to print it out or something like that. So that worked out pretty good. And then obviously the API is pretty easy to look at. You just look at the JSON, just whatever header you want to, and you can see there's all kinds of fun stuff in here for how to deal with JSON. Lots of different ways of manipulating it. And this actually, you can build up JSON with this too, which is kind of handy. Build it up programmatically. One of the things I noticed here is that the Podman output for names seems to have an array. So that's not exactly what I want. I want actually just the value and not part of an array. So I decided to add a little bit more functionality to the path expression that you can use by putting a subscript in there. You can see this is kind of funny syntax, and it's just kind of coincidence. I had decided to do both square brackets and parentheses in honor of C and also Plan 9 shell RC, which uses parentheses. It seemed to make sense. I just figured to make it easy by making it not too hard to figure out what you might want to use. And turns out that works fine too. That's where I used the regex in order to find out where the numbers are. So I used a regex here. A nice handy function from Libntech is string match captures. And yeah, just check at the captures and get those, get the name, which is the key, and then the number, which is the index that I want to grab. And it turns out that works fine as well. So that's good. And then trying to make a nice Unix tool with this JSON. We can also use it with cut. I put a tab in between the kind of key and the value, and then space separated quoted items come out just fine with cut with the -F2, which is field 2. So yeah, this is going to work for us.
Cool. Okay. Did you spot any other any interesting things in here that sparked any ideas as far as like other like interior functions or things that might bubble up user facing?
Yeah, I think this kind of simple query path that I made, I think it could be useful for pulling individual items out of JSON content. And we could probably make that part of the JSON API in Libntech, and by proxy, I'm sure we can figure out a way to make that available through the policy language as well. Which would be nice.
Yeah, because right now we don't have any native way of like querying JSON structure, I don't think, in policy language. You can pick out with merge data, you know what you're picking out.
Right.
But, or you can use merge data with JQ, but then you're working out to the JQ. Yeah, it'd be cool to see a little bit of more native queryability, I think, in the language.
Yeah.
Cool. Yeah. All right, Craig. Well, thanks for sharing a little bit of Libntech with us. And for everybody else, we're recording this the second time because the first time it didn't go. We already had our after hours chit chat. So join us next time for episode 62. Remember, we always stay around after the show to talk a little bit about whatever projects you're working on and share some ideas and get some help.
Yeah.
We'll talk to you next time.